Hello everyone and welcome back to the maths. In this video, we are going to look on how to graph an inverse function. In the previous video, we learned about the difference between an original function and an inverse function. And if you haven't watched that, I will try to put the playlist, specifically the function playlist, on the top right of this video. Right, let's try to get on into it. To actually learn how to draw the graph of an inverse function, I think we need to take a look at some direct examples. Let's say that the first function is this. I know the numbers is a bit bad, but yeah, let's try to deal with it, okay? Let's just say now that the domain is from -8 to 9, and then if we try to calculate the y value, or the range in this case, it's going to be from -4 to 2. Now, let's try to draw this in a Cartesian coordinate. So we have our Cartesian coordinate graph over here, and the length, the side of one square, actually represents 1 unit length, okay? Now, let's try to plot the boundaries of the function. We know that the first point is going to be -8, -4, and the second point should be 9, 2. And since this is a linear function, we can just draw a straight line and we are done. Now, let's try to draw the inverse function. So let's try to find the inverse function first. We know that it's going to be 17 over 6x plus 10 over 3. I think we all already know how to find the inverse function, right? Now, we also know from the previous video that the range of the inverse function is going to be the domain of the original function. And the domain of the inverse function is going to be the range of the original function. So it's going to be like this for both the domain and the range. Now, we can just try to plot the points in the graph. So it's going to look like this, -4, -8, and then 2, 9, and then we can try to draw a straight line. So there you go, that's the graph of the inverse function. Now here's the case though. Is there any special pattern? Is there any special relationship between the graph of the original function and the graph of the inverse function? We can try to take a guess. We can try to think of it a little bit. And now I will try to reveal the answer. So the graph of the inverse function is actually a reflection of the original function, because as you can see, it looks like a reflection, right? And it is reflected, but reflected in regard to this line. So it is reflected by the line y equals to x. It is a reflection. And this doesn't apply only to the line function. It doesn't only apply to this case. It applies to all cases. It applies generally. So the graph of the inverse function are reflection of f in the line of y equals to x. So we are going to see examples, other examples in the next few slides. Before we go into the examples, I want to tell you guys a bit another interesting fact about inverse function. Let's say we have this function. I will try to use an easier one so that we can calculate it easier as well. So this is our original function, and we know that the inverse function is going to be this. Now, let's try to find this composite function. Can you try to guess what will it be? Let's try to find out. So remember that a composite function means that the inverse function, in this case, the inverse function is going to be the input of the original function. So it's going to look like this. And then we can try to do some simple algebra, and we know that the composite function will result in x. Now, how about this case? Can you try to take a guess? So if we try to work on the composite function, in the end, we are going to get the same answer. So the composite of the function and its inverse is always going to be x. We don't care about the order, because in the end, the answer will be x. And this applies to any function that has an inverse. So it applies generally. Okay, now let's try to get on with the first example. So we need to sketch the graph of the inverse function, and we need to find the domain and the range of the inverse function. Now, in this occasion, I will try to draw the graph live. So I will not use any PowerPoint transition so that you can see how I sketch it. So the sketch is going to be very rough because we are actually sketching, but I hope that you can learn a thing or two on this occasion. Right, so we know that the coordinates of the original function is 0, -5. That's the first coordinate, right? And we know that the coordinate of the inverse function is the opposite of it. We just have to flip the x and the y. So the first coordinate of the inverse function is going to be over here. Wait, yeah, it's going to be over there, and it's going to be -5, 0. So you just need to flip the x and the y. That also applies for the second coordinate, 2, 7, which means we have to find 7, 2. I think it should be over here. So 7, 2. Okay, I will need to thicken this point, just like this. And now I can try to draw it. Remember, the inverse graph is going to be a reflection of the original graph. So we need to learn how the graph actually behaves. We need to feel the curve, as I should usually say. So I think it can be like this. Yeah, it's going to be very rough. Apologies for my bad drawing. Wait, I'll try to shade it so that you can see the... Yeah, I think it should look like this. So there you go. And as you can see, you need to put a little bit of the curve so that the function looks similar to the original graph. So there you go. This is the graph of the inverse function. It can be a bit curvier. I think it can have more curve, but yeah, I think this one will do. Right, so let's try to see the domain and the range. So the domain is going to be from -5 to 7, and the range is going to be from 0 to 2. Right, let's try to take a look at the next example. In this case, we don't know the exact coordinates of the points, but I don't think that will be a problem because we can just guess the points, okay? So let's try to guess the coordinates of the first point. I think the first one, it's going to be -1, -2, yeah? Like this. And I think for the second one, it should be 10, 2.5. Like this. And now, let's try to guess the coordinates of the inverse graph. Remember, the coordinates of the inverse graph is going to be the opposite of the coordinates of the original graph. So the first point, -1, -2, that means the points of the inverse graph should be -2, -1. So it should be over here, -2, -1. That is the first point. Now the second point should be 2.5, 10. I think it should be here. There you go. Now, let's try to draw the graph. So again, we need to get a feel of the curve. And I think it's going to look like this. Remember that it's a reflection, yeah? So we just have to reflect the graph. We have to imagine what it will look like. So I think it will look like this. The graph can intersect with each other, and that's fine, yeah? The graph can intersect with each other, and that's fine. Yeah, I think this one is going to be a very good approximation of the inverse. So this is the answer, guys. And as you can see, the domain is from -2 to 2.5, I mean. And then the range should be from -1 to 10. Right, let's try to get with the next example. So the next example, again, we don't know the coordinates, and we can try to estimate it. So for the first one, the one on the bottom, I think we can assume that this one should be 1, 0.1, I think, or 0.2. I think that's okay. And then for the second coordinate, I think it should be 3.5, 8. Yeah. Now, let's try to find the coordinates of the inverse function. So that means it should be 0.1, 1. I think it should be over here. 0.1, 1. I think it should be a bit to the left, but yeah, I think no problem in this case. And then the next coordinate should be 8, 3.5. 8, 3.5. I think over here. 8, 8, sorry. 8, wait, why is it so hard to write the 8? 8, 3.5. Okay, now let's try to draw the inverse. Again, we need to get a feel of the curve. We need to imagine what the graph will look like if we were to inverse it. So we need to imagine it, yeah? It's more like art rather than science. So I think the curve should go outwards and then inwards. Yeah, I think it should be like this. There you go. Yeah, I think this one is a good approximation. Okay, so that means the domain should be from 0.128 and the range should be from 1 to 3.5. Right, so these are the exercises that I've prepared for you guys, and as always, the answer will be in the description box. And this is also the second exercise. So we need to sketch the graph of the inverse function. Again, you need to have a feel of the curve of the original function and then reflect it, okay? So that's it for this video. In this video, we learned about how to graph the inverse function. We know that we should try to reflect it with the line y equals to x. What do you think about this video? Please leave a comment and don't forget to leave a like and don't forget to subscribe. I'll see you on the next video. Thank you.